Hi, so for this video I will discuss problem number 1851, minimum intervals to include each query. So it is marked as hard. Let's see. You are given a 2D integer array intervals where intervals will contain left and right. Describes the ith interval stands for left, starting at left and ending at right. So very basic one. We have 2D arrays with left and right. So basically this is an interval. This is an interval which start from left to ends at right. Then the size of the interval is defined as the number of integers in it contains, or formally left minus right minus left plus 1. That means both are included. If we have not included, then it will look like this. Like left is not included, right is not included, but every element in between is included, but not just this case, but everything. The size is right minus left plus 1. Simply, like if I have 2 and 4, then the size will be 4 minus 2 plus 1, that is 3. That means 2 3 4. Now you are also given an integer array queries. To the answer of the jth query in this is the smallest interval, size of the smallest interval I, such that left greater less than equals to query j and less than equals to greater than less than equals to right I. If no such interval exists, then the answer is -1. Return an array containing the answer of the queries. Okay, so let's take this example and try to run it. We'll try to understand what he wants to say. Okay, so let's take this example. So what he's trying to say is we have intervals 1 to 4, 2 to 4. Let's write in a clear way. So let's represent this on a line 1 to 4. Another one is 2 to 4. Another one is 3 to 6. Another one is 4 to 4. So this is just a line 4 to 4. Now what we want to do is we want to check the smallest interval size. We want size. The smallest interval size which actually contains query number. So okay, so let's suppose query number is 2. So we want only those intervals which actually contains 2. So 1 comma 4 contains it, 2 comma 4 contains it, this doesn't contains it, this contains. So we have only 2 candidates which can be our answer, and we have to pick the smallest one. So what will be the answer for us is the size of this is 4, this is the size of 3 is 3, so the answer for this one will be 3. Yeah, you can see that 3. Now for the 3, this one will consider, we'll consider this one as well, we'll consider this one as well, and not this. So that means the size of the is 4 3 3, that means the answer will be 3. Now for the 4, we'll consider this and this all will be considered, but the size of 4 comma 4 is minimum, it's only 1, then the answer will be 1. For 5, we'll consider not consider the first one, will not consider second, we'll consider third but not fourth. So we have only one option, so we just can't do much but just say 3 plus 1 4 is our answer. So that's how we have to solve this problem. Now let's see how we can solve this. So if you see the pattern in this problem, let me copy that. So if you see the pattern, what we want to do is for every element, for query element, we want minimum size of interval which actually contains it. Yeah, so let's discuss what we can do. First thing is, let's sort. Sorry for that. Yeah, sorry for that. Let's sort queries in ascending order and also sort our intervals in ascending order with the with our first element, based on our first element and then on second element. What does that mean is, this one is sorted. Let's pick another one which is not sorted. Okay, so let's see what will happen. If we sort the queries in ascending order, they will look like 2, 5, 9, 22. If we sort the intervals in ascending order, they will look like 1, 8, 2, 3, 2, 5, and 20, 25. So first based on the first element, then based on the second element. You can see here like 2, 2, but we've given preference to 3 because this one, because it has smaller second element. Now what we can do is we can use min heap, we can use priority queue, we can use tree set, and what we can do, like, because we have now in sorting. Let's say I iterate over the queries, and let's say I have first element as 2. Now I know my my intervals are also sorted. So in my any of these data structures, I will just add only those intervals which are relevant to my query. So for 2, I will just add this one. I will just add this one, not this one, and I will stop. From A, B, C, any of these data structure will help me to get my answer. Answer is the size of the minimum. But this is the set I have to consider if my query element is 2. Now let's move forward. We'll see why sorting will help and why this will become a sliding window kind of a problem right now. Sliding window and then mini heap kind of a problem. Now we come to 5. Now we see now these many are already in our data structure. Okay, so let's see, we see let's try to see if this became relevant now or not. Still not, so we'll not add it. But now again we check it. One more step. Out of the relevant elements previously we had for 2, how many are irrelevant now? So 1, 8 will still be relevant. 2, 3 is now irrelevant to me. Why I can remove this element from my data structure? Because I know all the next elements after 5 will be greater than 5, right? And if this element is not relevant for 5, it will not be relevant for any further element, right? Similarly, if any element is relevant for 2, right, it can be relevant for 5 as well. So we had A, B, C. We tried to add one more. We had tried to add further intervals, but that wouldn't help for 5. But now we are removing this B from our data structure because we know anything after 5 will not, this will not help. Now coming to 2 and 5, yeah, this will I need to keep. Now for 5 I only have 2 elements, and my again my data structure will help me to get the size of the minimum interval. Now come to 9. Now I will try to see if I can add the next set inside it. Okay, so I cannot, that wouldn't help. For 9 I will see if A is relevant. No, and it will not be relevant for 9. It will not be relevant for any other element because this is sorted in ascending order. 2, 3, it's already gone, so we will not see that in data structure, not this one. So our answer for this will be -1. So for this -1. For the previous one will be we had this one for 5, and answer would be this one, will be 5 minus 2 plus 1, 4. For 2 we had 1 A, B, C, and the answer would be, the minimum one is 2. Let's see, we'll confirm the answer. For 22, now we have nothing to consider, but let's see if we want to add this. Yes, we can add this. So this will be in our data structure, and this will be only element in our data structure because we don't have anything else. We already removed it. So answer would be simply for this will be 6. Let's see if I've answered it right. 2 minus 1, 4 and 6, right? So answer is 1 second, right, 2 minus 1, 4 and 6, right? So for us, answer for 2 was 2. 1 second. Yeah, for us answer for 2 was 2, correct, for him as well. Answer for 5 was 4. Answer for 5 was 4, right? Answer for 9 for us is -1. For him, okay, this is 19, but the answer is same for 9 and 9 because we don't have any element for 9, any interval for 9, any interval for 19, both for will be -1. For 22, his the answer is 6. Yes, we also get this. So let's move to the implementation then. So let's go to implementation and let's see how we'll implement this. So I'm using tree map, but anything else can be used. Any data structure, min heap or priority queue for this. Okay, and now we need to sort them first. Sort queries and then sort the intervals. Validator will have int. So we have to sort it based on the first element and second element. Yeah, and then let's iterate over the intervals for each query, like we did in the dry run. For each query, we'll try to see if we can answer it. If not, we'll assign -1. But first of all, we'll check what are the valid intervals for it. And valid intervals, I mean add intervals and remove intervals, right? And then we'll check the, so let's say, so if my interval is less than interval length, I still have intervals to be considered. I'm not over with all the intervals, and intervals, particular interval start is less than or equal to my query. Then I just need to put that into my also, like we discussed. Also, like we discussed, we'll use this data structure to get the element, get the answer what we want, right? Now what we'll store in this, right? So what we can store is the size, because we want the size, minimum size. If we keep the size as our primary element, then always in min heap I will have the top element with minimum size, and that will become my answer, straightforward, right? And another thing I can keep is the right. So as soon as I inserted some element, the element, I'm making sure by sorting, like this can be also important or valid for further elements. But once I know that this particular element or any element is this particular interval is not relevant for any of the value in query, any of the query value we have to answer, we don't need this interval at all for further elements in this element. So to remove that element, I will store right, and to get my answer, I will store the size. Let's see that in the code. So what I'm doing is I'm making the primary key for my map as size, and then I'm keeping this value as my right. Okay, this is done, the insert one. For the removal part, we'll do the same. Why? We have to check if our map is not empty. If we don't have anything in our map, then what will remove? And then simply the top element. If the top element value, that is the right, this is the right, this represents the right value of interval. If this is less than my query's element, Just remove it. We don't need that entry anymore, right? And then we'll go to the answer. So the order for our queries and order for the input queries is different. To maintain that, what we can have is we can simply have a hash map for it. So let's say and just say answer simply. And here what I do is if PQ is empty, like we saw for 9, we don't have anything. We can't actually have any interval for this. So we'll just simply say for the query I element, our answer will be -1, or else answer dot put what will be our answer. So our answer would be PQ whatever we have on the top, the key because the key is size. And then okay, need our original queries as well. So let's donate. And so now just we're gonna iterate over it. Original queries, we have I is equals to whatever answer we have for that value. Whatever answer we have that for value in our answer map, that will be sufficient, and we can just return the original queries. Let's see how it goes on the compile. Return integer dot compare. New comparator and oh. Do we need another bracket? Yes, we need that. Times limit exceed, why it's not, we have not incremented it, so it will just keep on considering the same interval again and again. Yeah, it works. Let's try submitting it. Yeah, it worked. So yeah, this is it for 1851. Just feel free to comment any other problem you want me to explain with the whiteboard and implementation. And yeah, thank you guys.